doing law. Then there's a break. So let's move over here. So we're on safety and law this week. Next week we get to do more law, but it's not going to be textbook reading. We have to read a couple of the Canadian legal documents that actually are what actually enforce what we have as regulations. So, and there's just 3 of them we have to read. You can read more if you want, and you have, I don't know, a lot of time on the bathroom to sit around and read through 60-some pages of, you know, the Radio Communications Act and such, but those are the 3 we'll be going over. They're already up online, but we will cover them at the end just so you can jot them down later. The other thing as well, this is the second last week for the dues for the course and such. I'm really generous, give you guys lots of time to get it in, but next week we have to let the examiner know how many tests to print. So for anybody who hasn't paid up yet and wants to be able to write their exam, you need to make sure that next week you have the $50 so that we can get your name on the list for getting the exam taken care of. So, other than that, we're moving straight along tonight. As always, did anyone have any questions from any of the readings? No? Okay. If you have any, feel free to ask. We'll roll right in this week. Unfortunately, lots and lots of text, so I'll be doing a lot of reading. But this one comes out of section 15. In the event of interference to a neighbor's television receiver, according to EMCAB-2, it will be deemed that the radio amateur's transmission is the cause of the problem if the field strength, A, at the transmitting location is above the radio amateur's maximum allowable transmitter power, B, on the neighbor's premises is above Industry Canada's specified immunity criteria, C, near the TV is below Industry Canada's specified immunity criteria, D, at the transmitting location is below the radio amateur's maximum allowable transmitter power.
Number 3.
Number 3.
I'm guessing one.
And we get number 2. So, that is, on the neighbor's premises is above Industry Canada's specified immunity criteria. So, what they're getting at is if the field is larger than the immunity criteria at the premises where the interference is being caused, then it's, if the field is, yeah.
It's your fault.
If so if on the neighbor's premises is above Industry Canada's transmitting criteria, if the amount is larger than the immunity criteria, it's your fault. If it's below the immunity criteria, it's their fault because their equipment isn't immune enough. So when you're building something that has to be RF immune, Canada has a set of guidelines on how much immunity it should be able to take, how much RF energy it should be exposable to. So if the amount of RF energy is larger, transmitter's the problem. If it's lower, it's the receiver's problem.
So what they would do is go to the neighbors and have some kind of meter and get you to transmit to see if how they would determine.
That is one possible course. Typically they'll try to do something a lot less than that. They'll say, have you tried a filter yet? Maybe toss a choke on it because they really don't want to send somebody out.
Tell them to move.
You tell them to move.
That's a very good attitude.
Is this something that happens commonly on tight neighborhoods?
I personally never heard of anybody who's had an RF complaint against them, but I've only been in the hobby 2 years. Laird, you've got somebody?
Oh yeah.
Against you?
Yeah, once. And actually, a friend of mine who's now passed away, he used to joke that he had the Worked All Neighbors Award. and one of them was an Industry Canada inspector. But he knew, in all fairness to him, this guy was running a totally clean outfit, and the guy across the street, even, you know, they were friends, and he said, no, all the interference that's being caused, it's not your issue. Again, due to regulations like this, you know, one lady had a TV that was like from the 1960s, and you know, no filtering on it whatsoever.
Yeah. Okay.
So,
Alrighty, and we're back. So, yeah, anyway, that's the way that goes. Which of the following is defined in EMCAB-2 as, quote, any device, machinery, or equipment other than radio apparatus, the use of functioning of which is, or could, or can be, adversely affected by radio communication emissions?
Did you reword that, or is that out of the book?
That's actually out of the law, yeah, out of the EMCAB-2.
In law?
Yeah, so under the radio regulations, there's a bunch of different documents that
Why did I
define
miss that?
different standards that we need.
I thought broadcast receivers.
I would think, yeah, broadcast receivers makes sense to me.
Yeah.
That's an awful hard question to read.
Right, radio sensitive.
Number 2.
Which?
Yeah.
Yeah.
So,
So-
that was my second
Yeah,
choice.
so they're saying any
Third
device,
choice was
machinery,
cable
equipment
television.
other than radio apparatus, for the use or function of which is or can be adversely affected by radio emissions. So it's anything that can be affected by radio. And it's the legal way of having to write that.
So just from a legal language point of view, it's broad as possible.
Exactly.
So,
Makes sense.
so Alex, can you have that stricken from the exam bank?
Unfortunately, no. No. You can just pray that it's not one of the 10 that it chooses for that particular question. But the other thing as well is every piece of technology is at some level radio sensitive. If there's electricity in it, some amount of electrical magnetic interference will cause it to break down. It's just a matter of how sensitive it is, of course. So. All right, according to EMCAB-2, which of the following types of equipment is not included in the list of field strength criteria for resolution of immunity complaints?
That's first answer.
Broadcast transmitters.
Yeah.
Yeah, so they don't care about your transmitter being interfered with. Sorry. But, all right, what does chirp mean? It's a program to program your radio.
Exactly.
Yeah, that's a. Number 3.
Number 3.
Number 3?
Agreed.
Yeah, that's correct. So, it sounds like a bird's chirp. All right, what can be done to keep CW transmitters from chirping?
Number 3.
Keep the filter.
No,
Keep the
power supply voltage steady.
Very steady.
Okay.
So, if this voltage suddenly shifts, which?
So what was number 4 there again? Sorry.
Yeah, of course. Keep the power supply current steady under transmission load. Yeah. So a sudden voltage shift can cause the initial oscillator to shift slightly in frequency before it can recompensate. So when you first key down, if the RF gets back into the power supply, it'll slightly shift the frequency for a second, causing that whip. So, which is one way to tell if radio frequency interference to a receiver is caused by front end overloading?
Number 4.
Number 4.
Number 1.
Number 1.
No, the intervention is all about the same. It is no matter. I thought it was 4. There was something about this question I didn't like.
So we got number 1. So if the interference is about the same no matter what frequency is used for the transmitter. So this would show it's overloading before any demodulation happens. So if it's something internal to the radio, then as you tune around, there'll be particular frequencies which are worse than others. If it's the same across the entire dial, it means that there's too much power being made into the receiver, and so everything is just being destroyed.
All right.
So, if a neighbor reports television interference whenever you transmit, no matter what band you use, what is probably the cause of the interference?
Number 2.
Number 2, too little transmitter harmonic suppression. Correct antenna length.
Well, there's
Number
something in
3.
there.
Yeah. So this is the overloading again. The key is that it says no matter what band you use. So what they're talking about is, if you're not familiar, over-the-air TV is also a receiver. It just receives particularly the frequencies that television used to use back before we went to HDTV. So the way to basically fix this problem, reduce transmitting power, and hopefully that'll take care of it. You're just essentially too close to the receiver. So, what type of filter should be connected to a TV receiver as the first step to trying to prevent RF overload from an amateur HF station transmission? Yeah, so it's the high pass. Over-the-air TV uses VHF and UHF, and your HF rig is lower, so if you use a high pass, it allows the VHF and UHF, but blocks the HF frequencies.
Is this actually the case now with digital TV, like Bob's?
Same thing, isn't it?
Versus
Yep.
the old analog?
So the main difference with the HD TV is now it digitizes and channelizes it automatically without you. So if you go to channel 2, for example, it's not a particular frequency. It's doing frequency hopping, but they are still using the VHF and UHF spectrum.
Oh, okay.
So, During a club ARRL field day outing, I don't know why they chose to toss them in, but we'll do it. Field day, reception on the 20-meter single sideband station is compromised every time the 20-meter CW station is on the air. What might cause such interference?
Those darn CW guys.
They're, both stations are generating and fed from the same generator.
I'll say 1.
Receiver desensitization?
Wow.
So, this is again, the transmitter's too close to the receiver. This is also called receiver overloading. So, intermodulation in a broadcast receiver by a nearby transmitter would be noticed in the receiver as
Number 3.
distortion in the transmission of voice peaks.
Distortion in the transmission. I like that. Alex doesn't like it, though, does he?
Can we move on? It's the undesired signal in the background of the desired signal. So this is one of those fun ones. Intermodulation. When you're getting that, what's happening is multiple signals are being demodulated at the same time, which leads almost to a ghosty sort of signal in the background. It's very typical in FM, though you can sometimes get it between FM and AM. If somebody has an AM transmission and an FM transmission, they'll sometimes demodulate incorrectly. But yeah, the two signals have become modulated together, and so you're demodulating, getting a sort of ghosty voice in the background.
I was thinking of simplex there. There's a question about simplex, and that's when you can receive and broadcast on the same frequency. Yeah.
Yeah.
I was getting too mixed up there.
That's fine enough. All right, if you've connected your handheld VHF transmitter to an outside gain antenna, you now hear a mixture of signals together with different modulation on your desired frequency. What is the nature of this interference?
That'd be your receiver's intermodulation interference.
Yeah,
Yeah.
that's correct. So, they're talking about multiple signals again being demodulated together. The difference is audio stage intermodulation interference isn't really a thing unless you've got multiple audio signals typically going through a mixer. That would be the only way to get that. And harmonic interference from other stations is a different type of problem altogether. So, two mobile stations are traveling along the same road in close proximity to each other and having trouble communicating through a local repeater. What might be necessary? Why might it be necessary to use simplex operation to communicate between these cars?
Number 1.
Yeah.
Yeah. Number one. So the strong signal of one mobile may desensitize the receiver of the other mobile receiver. Receivers do not like being near transmitters. This is because radio signals follow the inverse square law. The inverse square law just simply says as you move away from the source of something, it decays by a power of 2. So if you're really close, you have some power, and then as you move one equal distance away, you're now at the square root of the original power. And so it square roots again and square roots again, and the power gets much, 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 much smaller. So
That's the same with camera flashes, isn't it?
it is, yeah. So as it comes from a point source, it spreads out in a camera flash, and you get less light per distance. So
Have you explained how the repeaters work so they understand why that would cause a problem?
pretty much, yeah. I think we reasonably covered that. This was a question in one of the previous
We
ones.
did that last week, didn't we? The receivers and amplifiers?
Didn't you say if two people pull up to a light, you use that as a scenario, right?
Yeah. Well, this would have been which? 14. So yeah, last week we covered
Yeah.
it. So
Yeah, because when you're using a repeater, you're actually transmitting on a different frequency than what you're hearing.
Yes.
And that's why they can argue and fight each other and make lots of noise.
yeah, exactly. So, sorry. A television receiver suffers interference on channel 5. It's back when we used to use analog, but the question is still in the bank, unfortunately, which is 76 to 82 megahertz. Only when you transmit on 14 megahertz. From your home to see the tower, from your home you see the tower of a commercial FM station known to broadcast on 92.5 megahertz. Which of these solutions would you try first?
think we're back to D again. Low pass filter for at the antenna connector. You didn't like that.
Well, you probably should, but
That's not the right answer.
there's one that's a little better, yeah.
Yeah.
All right. So the answer is insert a high-pass filter at the antenna connector for the television. Now here's why.
That's right.
All right, I'm going to read this because it's way too tiny for you guys to read. This is also out of the Coils publication, so I directly copied it. The challenge here is to keep any signal out of the TV set in the range 76 to 82 megahertz. One possible source of interference is a harmonic of 14 megahertz. 5 times 14 is 70 megahertz, and 6 times 14 is 84 megahertz. The two harmonics are above/below channel 2. Add to this that you're a good operator and your transceiver is equipped with a low-pass filter, so your transmitter can be ruled out as one of the primary sources. So the culprit here is probably the FM station. One possibility is that its 94.5 megahertz signal mixes with your 14 megahertz signal, so there will be two products. A sum of the two signals, 52.5 plus 14 megahertz gives you 106.5 megahertz, and a difference between the two signals. 92.5 minus 14 is 78.5 megahertz. The latter falls right in the middle of channel 6. The solution, insert a high-pass filter at the antenna connector of the television, takes care of this frequency. So, everybody understand how that worked?
So when you oh, never mind, because that's who uses antennas anymore?
A lot of people.
I do.
I do.
Which?
Yeah.
I do.
Yeah.
I do. Have for years, and I love my antenna.
Yeah.
Really?
So,
Yeah.
Yeah, this question assumes
In
that
the
you
new
already
age.
have a low pass filter on your.
it does, yes.
Days and
Actually, I have
So-
five or six different antennas on my tower.
No shit. Oh.
So, anyway, the reason this question is kind of fun though is because it does show you that you can both add the signals and subtract them to get different harmonics as well of other frequencies nearby. So it is one thing to keep in mind. How can intermodulation be reduced?
C.
Yep. There we go.
Sorry, what's a suitable filter?
So a suitable filter, if you're using an HF station, would be a low-pass filter, right, to block off any of the higher frequency harmonics. If you're doing a VHF or UHF transmitter, more of a bandpass filter might be appropriate. So it depends on where you're broadcasting. So the assumption here is that you're dealing with interference in a receiver, of course. What devices would you install to reduce or eliminate audio frequency interference to home entertainment systems?
Bypass resistor.
Bypass resistors.
I was going to say 3.
3, coils on ferrite cores.
Oh, hey, you're in there,
So-
Jeffrey.
Coils on ferrite cores, they're talking about chokes.
Oh, they're chokes.
Exactly.
And that's a what's the name?
Yeah.
So they call it a coils on ferrite cores, which is just an inductor.
Looks like an AM antenna.
Yeah, essentially, kind of, yeah.
And those all in the old radios.
Yeah. Yeah, they kind of look like an AM antenna, I would assume, yeah.
Wouldn't
No.
that equipment have chokes on it already?
The material's the same as the old AM antenna, the old bar.
That's what I meant.
Okay.
That's what I meant to say.
Yeah.
That's what I meant to say. Yeah.
All right. What should be done if a properly operating amateur station is the cause of interference to a nearby telephone?
Oh boy. Oh boy.
Hang
I
on.
like seeing some of the ham's faces when you read questions, and they're just like, "Wait, what?"
I'd say number 4.
Yeah, for
Install a modular plug-in telephone RFI filter close to the telephone device. Yeah, so that's correct. That's the exact same ones you use if you have a DSL internet connection, and it filters everything except just the phone line.
Yeah.
You have a
So,
telephone in your house?
well, we do, yeah.
I do. Yeah, I do.
Okay.
What sound is heard from a public address system, or PA system if you've heard it called that,
Oh yeah.
if audio rectification of a nearby single sideband phone transmission occurs?
It would be number 3.
Number 3, distorted speech from the transmitter signal.
Absolutely.
Yep, that's correct. This is funny to play with in schools or offices. However, I do not advocate intentionally producing interference with any device you do not own. Just saying, it's a lot of fun. Moving on. What sound is heard from a public address system if audio rectification of a nearby CW transmission occurs?
On a,
Yeah.
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 So this isn't just CW though. This is that like magical buzzing noise you hear sometimes with people who have older smartphones. They'll get it near a system of like that's exactly because it's doing like modulation to get each of the different signals like Bluetooth or Wi-Fi out, and they have pretty poor antennas back in the day. So, but you'd hear the same sort of thing from CW transmitters, except more like beep 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 beep. So, all right. How can you minimize the possibility of audio rectification in your transmitter signals? Use CW only.
I would think number one.
Sure that all station equipment is properly grounded? Yeah, that sounds right. So, discussions. I didn't really think there was much else to say to that. Ground your stuff and reduce some of the harmonics and RF
I
you
just
got.
hope none of this is on the exam.
Don't worry, about what, 1/10 of it is, so the other 9/10 aren't.
You know, I closed the book this afternoon. I was reading.
Hmm?
I thought to myself, who and how did they allow this individual to write these questions?
It's true.
I mean, the only thing I can come up with this person is daft.
Oh, man.
Could
Alright.
be worse. It could be messages and seashells.
Oh yeah, of course. So, anyway.
Well done, Bob.
An amateur transmitter is being heard across the entire dial of a broadcast receiver. The receiver is most probably suffering from
4?
splatter from the transmitter.
Yeah.
No?
So, it's audio rectification in the
This happened to
receiver.
me just the other day, exactly that,
Hmm?
and it was CKDO coming through the amplifier. So nothing I could do, but it was grounding was the cure, of course.
Okay.
The radio, the AM station, CKW.
Yeah.
So yeah, the modulated radio signal is passing over a diode somewhere, probably in the power supply, and being rectified into an audio signal. So into the audio amplifier.
You got ratified up there.
Ratified? Oh, my bad. Sorry. I'll fix that up. But yeah. What device can be used to minimize the effect of RF pickup by audio wires connected to stereo speakers, intercom amplifiers, telephones, etc.? Magnets.
Yeah.
Just slap a couple on the side.
I think a diode, eh?
A diode?
And of course,
Ferrite cores. Yeah. So it's ferrite cores. It's a joke. Just a joke. Stereo speaker leads often act as antennas to pick up RF signals. What is one method you can use to minimize this effect?
shorten the leads.
Shorten the leads. Yeah.
Yes.
Yeah.
So shorten the leads. This works on most cables, not just audio ones. If you're having trouble with a particular frequency, you can also find a non-harmonic distance so that you try to make sure it's not an antenna. But that's only if you're having really bad problems and want to spend a little extra time. But otherwise, just shorten it as much as you can and it should take care of the problem. How can you prevent key clicks?
Use a key.
Number 4.
Use a key click filter. I want this question on my exam. It's
That's a hard
so...
I like this
Wish
question.
they were all like that.
This is a good type of question.
So a key click filter just suppresses abnormally high voltage spikes. So if there is a click coming on when a signal starts and it goes higher than it should on the voltage, it'll just try to round that out so you get the proper beginning. If someone tells you that signals from your handheld transceiver are interfering with other signals on a frequency near yours, what could be the cause? Two of the four don't make any sense.
No, number 2.
Number 2, your handheld has a chirp for weak batteries.
No,
Number 1.
No,
Number
no,
one.
wait.
Number 1.
So it's number 1. Your handheld is emitting spurious emanations. The only way you can really work out this answer is eliminate the other 3. You need a power amplifier for your handheld? No. Turn up the volume on your handheld?
No.
No. Your handheld has a chirp from weak batteries. It's not really what we're getting at with the question, so yeah. You're likely overmodulating is the real problem. So either turn on the microphone gain or talk farther away from the microphone. So if your transmitter sends signals outside the band, where it is transmitting, what is this called?
Off frequency transmissions.
Yep. Off-frequency emanations? No. Spurious. So, technically they're off-frequency, but they're calling them specifically spurious emanations because they're emanations you're not technically in control of. So, you're spuriously emanating.
That assumes that you are transmitting within the band.
Yes.
But your spurs fall outside the band because you're too close to the edge.
Signals outside the band. I guess yes, technically. Technically, if you were to have a transmitter that you could tune way outside the band and start transmitting, technically now you're just off-frequency emanation. Well, you're not off-frequency though, are you?
Yes, you're outside the amp frequency.
But I figured off-frequency would mean more that you think you're transmitting on this frequency, but you're off-frequency transmitting over here.
Well, the band is so wide.
Maybe, okay. Wait, sorry?
The band is, the band is a narrow band or a wide band. If you're outside that band, you're off.
So they're assuming that you're transmitting within the band, but the spurious emission carries it over the edge of the band.
Yeah.
I want you to know I got that wrong.
Oh, okay. That's fine. Don't worry. The best part is getting it wrong, learning you got it wrong, and then now knowing the right answer, right? So, what problem may occur if your transmitter is operated without the cover and other shielding in place? Beyond potentially sticking your hand in it and getting a nasty zap.
I would say number 3.
Number 3, it may radiate spurious emanations.
I don't know.
Yep, sounds about right. So the case is often a vital emissions control feature because they ground the case, and that helps take some of the RF that can be construed inside and grounding that as well. So, in Morse code transmission, local RF interference, key clicks, is produced by
Number 1.
frequency shifting caused by poor voltage regulation.
Power amplifier caused by high frequency. I like number 3.
So the key that they're talking about is local RF interference, and what they're specifically talking about is the actual electrical contact, sometimes sparking and causing a fuzz and a spatter like the key clicks. So, simple enough?
Can you go back just for a minute?
Yeah, of course.
Wave shaping is caused by poor voltage regulator?
No.
No, see, I'm getting too mixed up there.
So it's the making and breaking of the circuit at the Morse key.
Yeah,
The
that's off
answer
and on.
number 1 is for chirps.
Exactly. Frequency shifting caused by poor voltage regulation is the
Chirping.
the power amplifier, and is caused by the high frequency. This is not right. So, poor wave shaping caused by poor voltage regulation. Not really.
No.
Yeah, no.
Maybe chirp as well.
So,
No, it's number 4 because it's off and on. CW.
exactly. Yeah.
The signal's broken and then reapplied again.
Alrighty. Key clicks, heard from a Morse code transmitter at a distant receiver, are the result of
Number 2, I think.
So the key is heard from a distant receiver right there. So it's number 2. It's the sharp rise and decay time of the keyed carrier. So grab a marker because it'd be really quick to draw. If we imagine that we've got a signal that we're sending and we have nothing, and then suddenly we want to start sending a signal, if we come up like that and then we start sending our nice sine wave and then we turn it off and we get like a sort of pop up and pop down, that's where we're getting that sort of key click from. It's because it's coming on too quick or coming off too harsh. So we're getting a voltage spike.
Number 4 there, that was the old days of cathode keying.
Spark emitting from RF? Yeah.
And that was, you don't stick your fingers in the key, and, on the key contacts. And that didn't carry to the other end. That was,
It was local.
it interfered with your radios and mirrors.
Yep. So, yep, the over is overpowered at each end, causing the voltage peak and an audible click. So, in Morse code transmission, broad bandwidth RF interference, key clicks, heard at a distance is produced by broadband CW.
Number 1.
Shift in frequency when key right there. Poor shaping of the waveform.
Same question.
We just talked about that waveform a minute ago.
Exactly, they're talking about the spikes yet again. So, I love all the groans. What should you do if you learn that your transmitter is causing key clicks? Install a key kick filter.
Back to that choke.
The choke. Use a choke in the RF power output.
Late stages number 4, I guess.
There we go.
Yeah.
Yeah, check the keying filter, and then the functioning of later stages.
Yeah.
So, the filter should be taking care of the noise, so if you're having that noise, it's probably your filter's gone.
Just back for a second. Do we have what kind of filter are we talking about?
Key click filter.
Do we have a keying filter?
Most modern radios will have a key click filter if that's a problem in
Is
them.
it something that tangible that you can have in your hand, like?
Typically not. It'll be a part of the output stage, I would assume.
It's part of the keying circuit. Well, God, it's always complex.
It's not an external
A
filter.
CW transmitter these days is always a single sideband transmitter. So you pull one side down, okay, and for the balanced modulator, you unbalance the thing, and it puts out a carrier. But when you're doing this with the key going up and down, there's an RC circuit, and the resistor is adjustable. So you can start that square wave that makes key clicks, you can adjust it so it comes up slowly, and it goes down slowly. And it just sounds, the keying sounds too soft then. So but without that, it's a bang bang. Somewhere in the middle is just right. There's a long explanation. Yes. So
I
it's
like
a pot in there that you can adjust.
That's really cool. I did not know that. Now I do. Alright, so moving on. Yeah, the filter should be taking care of the noise, but it's variable, so you can depend on how much click you want on it. Alright, a parasitic oscillation. Generated by parasitic elements of a Yagi beam.
It's unwanted signal developing in transmitter.
Yeah. So, it sounds kind of like a tone building up inside your radio. So,
How are they asking that question?
yeah, of course.
They're just saying a parasitic oscillator.
Yep, oscillation.
Well, why don't they ask what they're looking for?
Yeah, if they did that, the test would make
That's not
way
very
more
defined, you know that, eh?
sense. I guess the way that they're writing this question is you only have 4 answers, so you can go through all of them, and then you have to just pick which one is most correct. So,
You're basically just finishing their sentence.
exactly. So what essentially they're trying to do is they're trying to test that you understand what it isn't more than what it is. If they said, a parasitic oscillation, I don't know, how would you word it? But I guess in this way, normally they'd ask, your radio is building up a tone, what is there's a tone in the output, what is that typically caused by? A parasitic oscillation? Here they're like, a parasitic oscillation, which is built up inside the transmitter, but they're trying to make sure you understand what it isn't, so that it isn't generated by parasitic elements of a Yagi beam, that it isn't or does not cause any radio interference. It does cause radio interference. Is produced in a transmitter oscillator stage. It's not produced there. It's produced internally through resonation, right? So that's why they're wording it in that way, is to try to test your ability to know what it isn't more than what it is.
And ferrite beads would be used to stop that.
Yeah. So, moving on. Parasitic oscillation in an RF power amplifier stage of a transmitter may be found. At high or low frequencies. Yeah, it's a weird way of wording it. What they're trying to say is it's caused by internal resonance and has no property of what frequency you're tuned to. So what they're really getting at is, if is the tone that you're producing on a harmonic frequency? Not particularly. It's indicative of the way the radio is built and the way the parts are laid out and that sort of thing. At high frequencies only, at low frequencies only, no. The frequency can either be a high pitch frequency or a low pitch frequency. So again, it's being caused by the transmitter, not by where you're tuned around in it.
You'd also see them in the AC chord, which is low frequency.
Exactly, yeah. So, transmitter RF amplifiers can generate parasitic oscillations.
Number 4?
3. Number 3.
Number 4.
You're right.
Yeah. So again, it has nothing to do particularly with where it's tuned, but you're not going to get a bad parasitic oscillation on frequency. It's going to happen off of frequency. So again, it's not tied to the selected transmission frequency. It just exists as a fundamental property of the way the radio is built. If a neighbor reports television interference on 1 or 2 channels only when you transmit on 15 meters, what is probably the cause of the interference?
Say number 1.
I like number 4.
Deionization of the ionosphere near your neighbor's TV antenna?
Yeah.
Whoa! I wonder how he got his antenna up to the ionosphere. That's the first question.
That's how high.
He's got balloons. He can pick up programming all around the world. Anyway, it's a harmonic radiation from your transmitter, likely. So if it's 1 or 2 particular channels, that's the problem. Oh man. So this is by Coils Publications again, so we'll just go through this. An important fact here is that the only interference is that there is only interference on 1 or 2 channels. Say it's channel 3, and this is on 60 to 66 megahertz. Check the range of the interference from 15 meters. Industry Canada says that the interference only occurs when you're on 15 meter band, which we know lies between 21 and 21.450 megahertz. If we might digress here, this question is very much pre-HD TV. With HD TV, you cannot assume that the TV signal is on the reported channel, and therefore you cannot assume that the station reporting as channel 3 lies between 60 and 66 megahertz. For example, in the Toronto area, CKVR Barrie reports at channel 3, but is actually on digital channel 10 DTV pilot carrier on 192.31 megahertz. The pilot carrier generally lies 310 kilohertz above the lower band edge, but may be offset to reduce co-channel interference. If you have TVI on your HD TV receiver, your first problem would be to discover what the true frequency of the station with which you are interfering is. A good starting point is an internet search or try Wikipedia. Our initial position here is that the harmonic interference from the transmitter is the culprit. A few simple calculations show that the third harmonic of 15 meter signal will fall between 63 megahertz and 64.35 megahertz, all of which lie in the range occupied by channel 3. Harmonic radiation from the transmitter is the most likely cause. You might suspect another possibility that the TV transmitter is suffering from front-end overloading because it's too close to your transmitter. This can be eliminated because the problem would be showing up wherever you showing up when you were on other bands and when the TV was on other channels. So, I included this mostly because it talked about the HDTV being on multiple different channels, and what's reported as channel 3 is a different digital channel on the back end. But what they're getting at is, when you're causing a problem on a couple particular channels for over-the-air TV, on a particular band, it's likely a harmonic problem. If you're causing problem no matter what band you choose, no matter what channel they choose, you're overloading. So, those are the keys to keep in mind. And don't worry about all the HDTV stuff, that's not even on the exam, it's just kind of fun extra knowledge. So. Okay, it's reported both of them at the same time. So, what is meant by harmonic radiation? It is unwanted signals at frequencies which are multiples of the fundamental chosen frequency. Sorry about that. Yep. So if you transmit at 14 megahertz, harmonics are at 7 megahertz, 28 megahertz, and so on and so forth. Why is harmonic radiation from an amateur station not wanted? Sympathetic vibrations.
Number 3.
Yeah, I'd say number 3.
May cause interference to other stations. May result in out-of-band signals. Yep. Never create out-of-band signals. Never. Just don't do it. So, what type of interference may come from a multi-band antenna connected to a poorly tuned transmitter?
That's a distortion. Number 4.
Number 4, auroral distortion.
Number 1.
It's harmonic radiation. Yep. So, auroral distortions. I don't know if you can distort the aurora, but if you can, let me know. Intermodulation, not really, and parasitic excitation, no. So, some bands are harmonic multiples of other bands, so it's one thing to keep in mind. One possible cause of TZ interference by harmonics from a single sideband transmitter is from flat topping, driving the final amplifier into nonlinear operation. The most appropriate remedy for this is
Number 2.
reduce microphone gain. That's simple. Yep. So your signal becomes choppy in your audio amplifier. So I'll show you an example of what this looks like. You might have seen it. But if you have some waveform and you're overdriving, what happens is you can end up going beyond the allowable limits of an amplifier. In which case what happens is you flat top. So it can't actually go beyond there. So you end up getting these hard flat tops at the bottoms to your signal. And it gets cut off, and it sounds very distorted, almost like somebody's put like a bag over the audio. So,
It sounds distorted to the receiving station.
well, because your transmitter would cap it at that point, your amplifier.
It's not getting out of the.
Exactly.
It's just in that. So somebody's tuned to that station.
Yep. So if you're overdriving, in that particular sense, your power amplifier can't handle it for the RF power amplifier. So you're getting that flat top on the transmission, so that anybody receiving it is still getting those flat tops at the end. So, right. In a transmitter, excessive harmonics are produced by
Number 3.
overdriven stages. That's correct. The more power you try to squeeze out, the more harmonic radiation you also produce. Harmonics may be produced in the RF power amplifier of a transmitter if
Number 2.
modulation is applied at high level stage.
Oh, 3.
Excessive drive signals applied to it. Yep. So, just reduce the power to reduce harmonics. That's the best way to go about it. Why do modern HF transmitters have a built-in low-pass filter on their RF output circuits?
Number 1.
Yeah, to reduce harmonic radiation, exactly. HF has a low signal and low-pass filter.
Thank you.
Yeah.
Which? Alright.
I'm doing good on my guesses lately.
Yeah, you're right on. You're right on, buddy.
What circuit blocks RF energy above and below a certain limit?
Bandpass.
Bandpass filter.
Pass
yeah.
filter? Yep. It passes a particular band of RF. What should be the impedance of a low-pass filter as compared to the impedance of the transmission line onto which it is inserted?
Twice the transmission line impedance.
Where's the transmission line impedance?
No,
Should be about the same. Anything else is going to cause a higher standing wave ratio, right? So as it passes into the filter, it's going to build up a standing wave, and then as it leaves, it's going to build up another standing wave. So you basically debalance the line. A band reject filter will. I think we should take a bit of a break soon. Everybody seems to get that. Brain's been working too hard.
no, I haven't got a brain today.
I'd say number 4.
Number 4, stop frequencies each side of a band.
Oh.
No. So it's
gonna
pass
say
frequencies
1.
each side of the band. So again, it's blocking a particular band, right?
Yeah.
You know, there's a common denominator there between 1 and 4.
Hmm.
Frequencies and bands.
Yep. So, alrighty, we're gonna take a bit of a break. Everybody seems to be getting a little bit flustered and tired.
Go ahead.
Alright, and welcome back. So, just moving right along. Alright, a high-pass filter would normally be fitted to at the antenna terminals of a TV transmitter, or receiver, sorry? That's correct, yeah.
Why are we doing TV?
So, alright, low-pass filter for HF rigs, high-pass for the TV. So, what we're doing here, televisions run on VHF and UHF, so we're going to apply high-pass filters to televisions, alright? For transmitters, specifically high-frequency transmitters, we're going to be using low-pass filters. If we're dealing with handhelds, we're going to be doing a band-pass filter. And on any of our other electronics, typically like audio amplifiers or stereos or something, we're going to be using chokes on them. So that's kind of the way they break down for the test and in real life. So, moving right along. A low-pass filter suitable for high-frequency transmitter would be...
Well, somebody's got to say.
I'm gonna guess number 3.
Number 3, attenuate frequencies below.
Nope,
No.
that's wrong.
So, yeah, no, not a problem. If we remember, a low-pass filter is going to pass the low frequencies, so it's going to attenuate the higher frequencies, right? And
Attenuate the higher frequency.
attenuate the higher frequencies. Means kill, yeah.
Yeah.
Yeah. So what we're doing is we're attenuating frequencies above 30 megahertz because below 30 megahertz is considered high frequency.
Just hold on just for one little minute there. Good job.
Alrighty. So yeah, so remember that HF band is 3 to 30 megahertz. So you want to attenuate frequencies above 30 megahertz, not below 30 megahertz. And the audio frequencies is just a red herring. So, what organization has published safety guidelines for the maximum limits of RF energy near the human body?
Health Canada.
Health Canada, yep. So, yep. RF is bad for your health, so it would make sense that the Health Canada is the one creating regulations on it.
We'll get that on the exam.
Yeah.
Alex,
Yes.
if you could just go back one, I think it's banned and it should be bad.
Yeah,
Am I right?
it's a spelling error.
Which
But yeah,
is
Oh,
banned for health. It is bad for health, not banned for health.
Okay.
So, again, I made these about 3 hours before I got here. Been pretty busy this week.
Were
So.
you drinking?
No.
yesterday.
Yesterday.
You were,
All right. Anyway,
I'm not gonna say anything.
what is the purpose of Safety Code 6? Everybody knows Safety Code 6, right?
I looked this up on the frickin' internet.
Oh, really?
There's 101.
Number 1.
Gives RF exposure limits for the human body?
No.
No? Uh-oh. Well, it does give RF exposure limits for the human body. Interestingly, if you try to Google code 5 or code 7, it'll say, are you sure you didn't mean 6? So, yeah. Health Canada published Safety Code 6. There is no 3, 4, 5, 7, 8, or 9. I couldn't find any of them. But they call it Safety Code 6, and it has to do with RF exposure limits on the human body.
Yeah, wasn't there a question about something in a handheld and...
Yeah, you keep it in your head.
Yeah, I heard.
Yeah.
We read
Those will be coming up.
in the questions, yeah.
Those will be coming
Keep
up.
it in your head.
Oh, yeah, sucker, eh?
All right. According to Safety Code 6, which frequencies cause the greatest risk of RF energy? Sorry, from RF energy.
B number.
Number 4.
Number 4, above 1.5 gigahertz.
Yeah. No, yeah.
2
Yep, there you go, 2.
to 300.
So just above HF to the end of UHF, essentially. So, it's subjective, but I say these are the most fun. So, anyway, we'll just move on before I get yelled at by all the HF people. What is the limit of exposure to RF the lowest in the why is the limit of exposure to RF the lowest in the frequency range of 30 megahertz to 300 megahertz according to Safety Code 6?
Number 2.
Number 2. The human body absorbs RF energy most in this range. That makes the most sense. So.
Boy, Jeffrey.
Yeah, alright, and there is one place in particular that absorbs this, which will be coming up soon in a question. According to Safety Code 6, what is the maximum safe power output to the antenna of a handheld UHF or VHF radio?
25 watts.
25 watts, yeah.
So,
That's specified.
Not
Oh,
specified.
specified.
so, this doesn't mean what you initially may think it means. The exemption for portable equipment was withdrawn in 1999. It now has the exact same requirements as any other device. So this is one of those questions that they're really trying to get at you with. Yes, technically, but not really. It's not 25 watts specifically. It has to do with power density. But what they're getting at is that for anybody who's remembered the old days back when portable radios didn't have a maximum RF output, under safety code 6, that's been withdrawn. They're now the exact same as any other transmitter, so it's not specified. It's a weird way of wording it, but yes. Yeah.
What does overexposure to RF radiation do? Does that give you cancer or drive you insane?
So it may cause cancer in some extreme cases. The most prominent damage that can happen is eye damage.
Oh, okay.
RF energy will heat the skin of the body.
Yeah.
And the eye is kind of like an egg in that it's basically a protein sac, which can start to cause things like cataracts and other nasty things.
Oh, poached
So
guy.
you end up voting for Trump.
Didn't catch that joke, but moving on. Which of the following statements is not correct?
I'm so tired from freaking reading today.
Number 3. Permissible exposure levels of RF fields increase as frequency is decreased from 10 megahertz to 1 megahertz. Everybody's still reading, so I'll give a few more seconds.
I thought 4.
I was going to say 4.
Yeah, I
Permissible
thought 4.
exposure levels of RF fields
It's a
decrease
close
as
one.
frequencies decrease below 10 megahertz.
It's a hard
It's a
question.
tricky one, yeah.
It's a hard one.
So you just gotta get the decrease, increase in the right proportion for the particular
Alex
place.
is going to give us a permissible exposure levels to RF.
Yeah, I am.
Yeah.
So if we remember correctly, they decrease below 30 megahertz. So if we go back, permissible exposure levels to RF fields, we don't want to worry about that, decrease as frequency is decreased below 10 megahertz. Technically, it's anywhere below 30 megahertz, so 10 megahertz is down there. Number 3, permissible exposure levels to RF fields increase as frequency is decreased. That would only make sense between the 30 and 300 megahertz. So in that range, it's very tight, and the amount of energy you can have is low, but outside of that, it gets more and more and more and more and more. So you can kind of imagine it as a sort of shape like this in terms of power. So the permissible exposure levels of RF fields
Number 3.
decrease as frequency is increased above 300 megahertz.
I'd say 4.
I'd say 4 too.
4. Oh, you're right.
You're smart,
You're a
you!
good guy.
Just above.
Sheesh.
That shouldn't be correct.
I thought it was 4.
Oh,
Yeah.
4.
I will double check on that
Take
one.
that back.
Sorry. Increases as frequency is increased from... No, so it'd be
The higher the
increase,
frequency, the more damage it can do.
only in the 30 to 300 megahertz. Beyond that, the human body doesn't really interact too much with the radio at
See,
that
the
point.
permissible exposure level. So it should be increased as frequency.
You know, I went to Winnipeg
No,
on this, you know.
Yeah, so the permissible exposure level increases as frequencies increased from 300 megahertz
Yeah.
to 1.5
That's why I
gigahertz.
say 4.
That should be
I'd say
correct.
4.
So,
Yeah, tell him.
Yeah, he's
That's
No, 3 is the answer. 3 is the
I'm pretty
answer
sure.
because it's
So I will
increased
double
above
check, but
300.
as far as I'm aware, it should be number 4, shouldn't it? Yeah,
Roger.
that's what I thought. So
I want to launch a petition.
if you get that one on your test, let me know and I'll take a look at it. So, which statement is not correct? They love these questions.
Number 3.
Safety code 6 uses different units for the magnetic field strength and the electric field strength when stating limits.
I'd say 4.
Safety code 6 specifies lower exposure limits to the general public in uncontrolled areas than it does for people in controlled areas.
We're weeding them out. There's only 2 left.
I didn't say any of those were wrong. I just see a lot of people very intently like, so. A couple more seconds and... Handheld transceivers are excluded from safety code 6 requirements. So they're not. They are entirely within safety code 6 limits. So
That's wrong.
Yeah.
What it is, we go back to the last question.
Which,
The one was talking about that safety code. That one.
It's tricky.
And the answer is, handheld transmitters are excluded from the safety code 6 requirements.
What are control
Yeah, but it's saying which statement is not correct.
yeah.
Let's go back to the one.
That's tricky.
You know, there's so many words in this thing, and, not, be. You gotta
Yeah.
read. What did Jeffrey? Was it Jeffrey that said you really, or was it maybe Steve? I think it was Steve. You gotta read every freaking
No,
word.
no. This
Oh,
says,
that's Jeffrey.
Yeah.
No. The
Yeah.
first one said that, this one says is not correct.
Yeah. So that's where it's really hard to read through these questions.
Transmitters
because-
are excluded from safety code requirements.
Exactly. So handheld transmitters are not excluded from Safety Code 6 requirements. They must meet Safety Code 6 requirements.
Absolutely.
Prior to 1999, there was an exclusion saying handheld transmitters don't count. They're too low power and we're not going to regulate them.
We talked about
I still
that,
have trouble with
James.
the two questions. Look,
Yeah.
To me, it looks like they're opposite.
Yeah.
It's
Yeah.
Yeah, but see, this one's saying is which statement is not correct. And the first statement is saying handheld transmitters are excluded from the safety, but they're not excluded. They're part of the safety.
Yeah.
Yeah.
So the statement is which is not true.
Yeah.
Exactly.
Yeah.
So this one is not true, this one is true, this one is true, and this one is true. So,
Out of curiosity, what are controlled and uncontrolled areas?
This is saying, this one's saying that the handheld transmitters are not excluded from safety code 6. It's
so
being true.
okay. So what's saying is handheld transmitters are excluded from safety code
No, they're
requirements.
not.
No, they're
No,
not.
they're not.
That's
Go
right.
back to the other one.
Oh, my bad. I've been going the wrong direction. Um, and it should be
Yeah.
You
Oh,
just passed.
yeah. There
That's
you
it.
go.
no, because we're going to the one about. There we go. So according to Safety Code 6, what is the maximum power? It's not specified because the exemption for portable equipment was drawn in 1999.
I'm sorry.
Yeah.
According to safety code 6, what maximum peak power will maintain?
You know, it's all about wording.
So it's not,
is.
it's not excluded, but it's not specified.
So exactly. Before, what would happen is it would say handheld transmitters are excluded from the regulations. So it was specified that they didn't have a maximum power output. Now it doesn't distinguish between a handheld transmitter and a base station transmitter. So the handheld is not specifically specified. It specifically says any transmission. So
And this question here
That
is
makes it confusing.
yeah,
It
but-
does.
But
Because
this
it is
question,
specified
Sure does.
as any transmitter.
exactly.
but this is talking about the power output too.
Yes.
Okay, so all they're saying in this question is they're not specifying what the safe amount of power to use is. So whether you're using 100 milliwatts or 5 watts, they're not saying that the 100 milliwatts is safe and the 5 watts is unsafe. They're just not specifying anything.
Literally, he's just saying it's
Well, no.
Well, for
So
other transmitters, if they are, then they are for this.
honestly, they should really reword this question. It's very poorly done. What they should say is not specified because handheld transmitters are classified as any other transmitter. Yeah, it's law.
It's fun.
It's fun. I think we went a little too far.
Oh, that was all right. But I wanted to get into that grounding. That's good stuff. Should have another coffee break.
We should have another coffee break. There we go.
Breaking or something.
Nope. We had. There we go. So handheld transmitters are not excluded from safety requirement 6.
Number one's correct.
Yeah.
And what were controlled and uncontrolled areas?
Yes. So controlled and uncontrolled areas. Not exactly sure.
Gray area?
Yeah. Well, I think a controlled area would be something that the operator controls the area. So like your backyard would be a controlled area.
Yeah.
But uncontrolled area would be in a public setting, I would assume. But
I think that's right. I think a controlled area is where people work with RF, for instance, in this case.
okay.
Or a hospital.
Uncontrolled area is the rest of us walking around the street and we don't know about it.
Yeah. So that would also make sense. So if you're on like an RF test range or you're working around antennas, that the people there that are a part of that know that there's RF happening. That's a controlled area where everybody is aware of the safety regulations. Uncontrolled just means the general public is around it.
So we're still talking about radio.
Yeah. Yeah, we're still talking about radio.
still talking about radio frequency.
Mhm.
Yeah, good.
Okay. Which statement is correct?
Two.
Safety code 6 sets limits for RF exposure for all radio transmitters regardless of power output.
Yeah,
Yep.
I like that.
So, the other thing I would say, don't read safety code 6. It's a lot of tables that have different, if you're in this power band, then this is the maximum voltage per meter, and this is the maximum voltage per square meter. Don't bother going through that. It's a lot to read, and unless you're building a transmitter, it's not really important. It's just kind of important to understand the health risks you play around with when you're doing radio. So, yeah, again, you should take a look if you're bored, but that would be about it. Which of these statements about safety code 6 is false? Man, they love these ones.
Oh, yeah. Do we have to? We can skip this one.
Hands up to vote to skip.
Industry Canada's got to skip. Which of these statements about safety code 6 is false? 6 limits include current, electrical, field strength, magnetic field strength, radiation. 6 limits allow the rate of radiation environment absorbing the body. Fixed code has power. Number 3.
Number 3? Number 4? Number 3. Safety code 6 sets limits in terms of power levels fed into antennas. That's
Hoorah.
false. They do everything else though. So what they specifically state is the limits of the electrical field strength given in volts per meter, RMS, the magnetic field strength in amps per meter, RMS, and the given power density, watts per square meter, right? So it's a measure of area over a given period of time in minutes. So typically they'll say, given 6 minutes of exposure to a field strength of this, this, and this, that's within limits. Anything more is outside of limits. So if you have more electric field strength or more magnetic field strength, or there's a higher power density, those fall without the limits, and now you've got a health concern.
So if you got a really powerful system, keep your transmission short.
Exactly. Yeah. There are certain bands that have instantaneous rates. So some of them will be over 6 minute periods, other than will say instantaneous. But yeah, the best advice is kind of stay away from an antenna when you're using lots of power, or if you're in that 30 to 300 megahertz band.
How far should you keep an antenna away from people?
Well, the best bet is keep it as high as possible, right?
What is considered to be, you picture this antenna on top of your house, it's radiating on your house.
Mm-hmm.
So your family's going to get the worst of it to start with.
That's true. I'd say 20 to 30 feet would be pretty good for an antenna if you can get it up that high. You should be fine, especially if it's outside and you're inside. I don't think, if you wanted to, I guess you could determine what you feel safe with in terms of proximity. Definitely keep it away where somebody could touch it. Don't let people get close to it to do that. You are feeding lots of power into it, and you can actually get burned touching it. But yeah, it's always just a matter of as far away as you can. It always depends. If you're in an apartment complex, for example, you may have to keep it inside the room with you. So just operate on lower power. If you have a nice big farm property, down on the field would be great. So
If I put mine in the
You can actually find
backyard,
this online, there are calculators.
200 feet
Okay.
away from the
European
house.
ones though.
Oh, of course.
So what I only found it is for magnetic. The reason I'm asking for magnetic, you can get magnetic loop antennas, but the antenna adjustments are right at the base of it. Some of the stuff in the 1920s was like a cross that sat in the radio with a
Yeah, I like
loop
that,
wrap.
eh?
You can actually buy those things today, but your rig's standing in front of it, adjusting transfer.
Oh yeah, that's that line. Did you get that
Okay.
from from Durham?
So apparently there are calculators if you want. Google around online, I guess, and take a look.
I'd like that guy.
So-
You're talking about the handhelds, like don't talk to the handheld.
Mhm.
But then again, how far do you keep that away?
Exactly. So again, if pull up my radio here. So technically, when I talk into this, it's like 2 inches from my face, directly in front of my eyes and head. Probably not the best to be doing that, but it's always a matter of how much power and how much of a risk are you willing to take. If I were on this all the time, I would probably get an external mic for it so I could keep it away from me.
And then where would you put it?
Probably down here on my
On
hip.
your belt, so you're your hip would get it.
Exactly. So again,
Radiation in the hip?
Well, your
Yeah.
eyes are more
Better than the
sensitive.
eyes.
yeah. So it's best to keep it away from the face if possible. But again, it's always a matter of how much risk you're willing to take.
Yeah, we have those at work. We put an earpiece in. So,
Yeah.
So do we get radiation in the ear?
Nope. So
That's audio.
it's the
Audio,
antenna.
Yeah.
So, I do have an earpiece as well, but it looks like Secret Service. It's like a little flexible tube.
That's what I
so,
got. That's
oh
what I
yeah,
got, yeah.
yeah. If you ever walk around with those things, up people are like, oh,
I gotta go do it.
that's security operating day.
I'll show you.
Alrighty. Power line voltages have been made standard over the years, and the voltage generally supplied to homes are approximately
120, 240.
120, 240.
Yeah.
So, AC voltage supplied to homes can be as low as 100 and 200 volts and as high as 130 and 260. This is further complicated by the frequent reference to 115 volts and 220 volts. So simply remember the answer that they want is 120 and 240, but it can vary.
And it always varies these days.
Yeah.
Our equipment is susceptible to grounds.
Oh, really?
It shuts
Okay.
itself down. We have to go on a service call to reset it
Oh, man.
frequently in summer.
Oh, really? Oh, I guess in summer, yeah, you always got the air conditioning kick in. No, actually, interestingly, apparently there's something in Europe called the tea kettle brownout. So at 7 o'clock, they have this entire thing where everybody in the country at one particular time turns on their kettle. So they have to have like a lot of standby generators every night to kick in at that point. So, yep. The electrical grid is much more complicated than plug it into a wall.
Number 3.
Wire fuses needed to close as close as possible to the vehicle battery when wires are traveling directly to the battery. Number 3.
Number 2. That's wrong.
You start a fire.
Always remember in fuses that the fuse is there to protect the upstream equipment like the battery. The downstream equipment's already blown up.
Yeah,
That's
basically.
what caused the fuse to blow in the first place.
Yeah, exactly. If your battery is overfused, there's a big problem with the battery. It's got enough more power to draw.
To protect the overcurrent from starting a fire?
Yeah, if you have a short in the line.
Yeah, but if you